Want GED Science Practice Questions to help you pass GED Science? Then you're in the right place. In this video, we're going to look at the GED Science questions that the GED testing service provides for free. And if you're new to my channel, my name's Parker. I make videos often to help test takers pass the GED test, and you can get started by clicking that subscribe button down below. Okay, the first question. The map shows the Earth's continents, the outlines of the plates that make up Earth's outer shell, and the locations of volcanoes. Which conclusion can be reached from the information on the map? So here we have our map and we've got multiple answer choices here. Now's a good time to pause the video, try this out, and then we'll go over it. Okay, so let's go over this one. So it's always important to look at the data and the information given you closely when you're given a map or a chart or a diagram or any picture really on the GED test. So it's always important to look at the title of the map. So we see world map of the continents, places, or plates, and volcanoes on Earth. So it's always extra important to pay attention to a key if you're given one. So the key tells us that the yellow dots are active volcanoes, which we see here, and the black lines are the plate boundary lines, and also the red line is the equator. So let's go through the answer choices and we can use process of elimination to figure this out. So when in doubt, use process of elimination. That's going to be your key for most of the multiple choice questions on all sections of the GED, but especially the science. So A says that volcanoes are scattered randomly across Earth. So we do see some dots and they do appear to be kind of in random places. So it's hard to rule A out, but at the same time, it's hard to reach that conclusion. So let's leave A in. We won't eliminate it just yet. It's unclear if this is going to be right or wrong. So answer choice B says that volcanoes are only located along edges of continents. So the continents are these green areas on the map, right? So they're not labeled here, but this would be North America, South America, Africa, and so on and so forth. Okay, but we see that there are some dots meaning active volcanoes, right? The yellow dots, they're also found in the continents, right? And they're also found, some are in areas that aren't even in the continents, right? They're not on the land, okay, according to the map. So we know that this is false. So even if we look along the edges of continents, right, we don't only see volcanoes there, they're in other places as well. So we can rule B out. And anytime you see words like only or all or never or none on a multiple choice test, you always want to just think closely about that answer choice because they're probably going to be wrong. Not all of the time, but in many cases. So answer choice C says that volcanoes are mostly located along boundaries between plates. So remember that the black lines represent plate boundary lines. Okay, so if we trace these plate boundary lines, we do see that most of the active volcanoes are along those lines. So this is looking like the correct answer. But let's also look at answer choice D. So if you have enough time on your science tests, it's always good to try to rule out all answer choices. But if you find yourself pressed for time, then don't worry about ruling out every answer choice after you found one that appears to be correct. So it says volcanoes are distributed equally in the northern and southern hemispheres. So the red line is the equator. And if you're not familiar with what the equator is, it's an imaginary line and it divides the Earth into the northern and the southern hemispheres. So if you actually go down near the equator, there's not actually a physical line there, right? It's just an imaginary line and it separates the northern hemisphere, which is up here above the line, and the southern hemisphere, which is below it. And just by looking just quickly with our eyes, we can visually see that there appears to be many more yellow dots up here in the northern hemisphere than the south. And technically you could count these all out and you could see that, but I think it's pretty easy to see that there's more yellow dots up above the line, so they're not equally distributed. So that leaves us with A and C, and this illustrates another important point about multiple choice tests. In some cases, you might see answer choices that both appear like they could be right, so when that happens, you want to go with the one that seems to be most right. So remember that the question says, which conclusion can be reached from the information on the map? And this conclusion A, volcanoes are scattered randomly across Earth. It's hard to reach that conclusion, but it's also hard to rule this answer choice out. So it looks like it could be right, but C is definitely more right. So we can definitely draw this conclusion clearly, so that's why C is the correct answer. So let's check it, and we did get this one correct. And so if you want to, you can pause the video and you can read their explanation for it if you'd like, and then we'll move on. Okay, question 2. The diagram below shows a typical energy pyramid. Which statement correctly describes the flow of energy through the pyramid? Okay, so go ahead and pause the video and look at the answer choices and try to figure this out, and then we'll go over it. Okay, so for GED science questions, a lot of test takers sometimes panic when they see a question and they don't know much about the topic. So maybe you saw that the topic was the energy pyramid and you thought that you'd have to have a lot of background information and knowledge about the energy pyramid to get the question right. And that's simply not true. So GED science, it's problem solving, critical thinking, and looking at charts and data and drawing conclusions. So it's not a memorization test. So you don't have to know anything about the energy pyramid to get this question right. Now that being said, okay, the more information that you understand about the sciences, the better off you're going to be. You're going to get questions right a lot easier, but it's simply not necessary. So the energy pyramid, well, let's reason our way through this. So we see that there are different levels here. The producers, primary consumers, secondary, and tertiary. So what you're supposed to see here is that there's different energy levels at the different levels on the pyramid. So we see, look at the green area on the producer level compared to the green area on the tertiary consumers, right? So which has more green? Obviously, we see that there's this little triangle up here, which is the tertiary consumers, and this big green area down here for the producers. So obviously, the producers have more energy than the tertiary consumers, right? So we can say that energy gets lost as we move up the pyramid, right? There's less energy at each level. So let's reason our way through the question. All of the energy from the lower levels is available to the top level. So we already can see that that's false, right? Because we know that at each level, there's less energy available, so that's false. B says that the producer level directly provides energy for all of the other levels. And what you're supposed to see is that the producer level, it's directly below the consumers. So see that the producers and the primary consumers, they touch each other here, and the tertiary consumer level, right, it touches the secondary consumer level on the pyramid. But the producers, it's not directly connected to the tertiary consumer level. So we need to draw the conclusion that the producer level directly provides for the primary consumers, and then that's it. So primary consumers feed on the producers, and the secondary consumers feed on the primary consumers, and tertiary feeds on secondary. So we know that B is false. The producer level does not directly provide energy for the other levels. So what about C? The highest amount of energy is transferred between levels that contain consumers. So the producer level has the most energy, and we know that energy is transferred from the producers to the primary consumers. So we know that the highest amount of energy is not transferred between levels that contain consumers. So what about the last choice, D? Energy is directly transferred from primary consumers to secondary consumers. So we see here are the primary consumers, and the energy, yes, it is directly transferred to the secondary consumers. So here's our correct answer. So if you understand science here, right, you would have a better understanding of the energy pyramid, but see how it's not necessary if you just reason your way through the question, okay? Because the way this works is that the producers are plants, and the primary consumers are animals that feed on plants, such as deer and rabbits and insects like caterpillars, and then the secondary consumers feed on primary, and so on and so forth. And heat is always, or energy is always lost as the trophic levels increase. Trophic levels are just the different levels here. That's another word for them. But basically, metabolic heat is always released when one animal feeds on another animal, and we see here that energy is being lost as we go up the pyramid, and the plants are the producers. The plants make their own energy, all right, they make their own food from the sunlight through photosynthesis, which we don't need to get into in this video here, but the point here is that you can either look at it scientifically based off of scientific information that you know, but you can also just reason your way through the questions too. All right, so let's move on here. So question 3 says, a scientist collects data on the solubility of different salts at different temperatures. The results are shown in the graph. Which conclusion is supported by the data in the graph? And so here we see the graph, and so let's pause the video and try this out, and then we'll go over how to do it. So let me show you the question here. So here's your question again, and then here's the graph. So go ahead and pause the video and try to answer the question. Okay, so In this case, we have to look at the graph. So it says salt solubility graph. Salt solubility at various temperatures. And so we see increasing solubility, okay, over here on the y-axis in the graph, and we can think of this as like our vertical axis, and we've also got horizontal axis down here, right? So these are different temperatures. So we see 0 degrees, and these are temperatures in degrees Celsius. So it would be 0 degrees, and then this line, this would be 10 degrees, 20 degrees, 30, 40, and so on and so forth. And so we see that solubility increases the higher we go up on the graph here, because it says increasing solubility. So the lower we go, the less the solubility is. And then we're going to see we've got PbNO32, and we've got NaCl, which that's just salt. That's like your table salt, right? But anyway, so you don't have to, again, you don't have to know that much background information about solubility, chemistry. You just have to use common sense, and you just have to look at the conclusion that the data points to. Okay, so let's use process of elimination. Solubility always increases as temperature increases. So remember how I was saying that words like always or never, these are usually clues that that answer choice is wrong. Okay, but let's confirm that. Solubility always increases as temperature increases. So let's look at for PbNO32. Okay, here's the red line. So as the temperature increases, so we see the temperature gets hotter, right, as we go from left to right, and solubility increases going from down to up, so moving up. So for the red line here, right, we see that solubility increases as temperature increases. So let's check KNO3. So for this light blue line, again, if we just follow the line, we see that, yes, solubility increases as the temperature increases. So the hotter it gets, the more soluble. And so for the yellow line, we don't see as great of an increase in solubility, but if we just follow the yellow line out here, we see that, yes, solubility, it does increase slightly as temperature increases. All right, but what about, all right, so for KCl2, we also see that the green line here, which is the KCl, as solubility increases, okay, temperature also increases, right? So what about the Ce2SO43? Well, we see here if we trace the purple line that what's happening here. Well, this line it's going in the opposite direction, so it's going down. So we can see that as temperature increases, the solubility decreases for the purple line here. So solubility does not always increase as temperature increases. Okay, so this is false. So B says at 40 degrees Celsius, KCl has the highest solubility of the salts at the table. So let's use process of elimination for this question. So at 40 degrees Celsius, so that should be a dead giveaway that you want to find the 40-degree temperature, right? So this right here is 40 degrees Celsius. So it says KCl has the highest solubility at that temperature. So let's find KCl. Which color is KCl? Hopefully you can see that the green line represents KCl. So at 40 degrees, let's look at the solubility level of KCl. So right here so we find 40 degrees. Right here is the solubility of KCl at 40 degrees, but it's not the highest, right? Because at that same temperature, we see that the blue line here, which is KNO3, and the red line, which is PbNO32, okay, we see that they both have higher solubility levels at 40 degrees Celsius. So therefore, this is also false. So we're now down to C and D. So C says the rate of change in the solubility of KNO3 changes as temperature increases. So you might be thinking, the rate of change in solubility changes as temperature increases. So what in the world could that possibly mean? Well, let's skip this answer for now and let's look at D. The solubility of NaCl does not increase with increasing temperatures above 80 degrees Celsius. So again, let's find 80 degrees Celsius on our chart here. And this answer choice is in regards to NaCl, which if we find in our graph here, we see NaCl, that's gold. So let's look at 80 degrees. So here's the 80-degree temperature, and we find NaCl right here. And so we can see that the solubility, it does increase above 80 degrees, right? So if the temperature is at 80 degrees and we crank that up to 90 and then up to 100, we do see that the solubility is increasing. Okay, it's not that much of an increase, but as we crank the heat up from 80 to 90 to 100, we do see an increase in solubility. So this answer choice is false. So the only thing that could possibly be right is this answer here. The rate of change of the solubility of KNO3 changes as temperature increases. So you don't even have to know what the rate of change means to understand that this is the right answer. So see how just by using process of elimination and just reading an answer choice and then looking at the graph and seeing if that's true or false, we were able to figure out that this question was right. So here's the explanation and the answer rationale. And the answer rationale says that the rate of change in solubility of KNO3 changes as the temperature increases. The curve in the KNO3 line demonstrates that solubility does not increase as a constant rate as the temperature increases. And you could pause the video if you'd like and read this, take your time, but I'm going to explain to you what this means here. So basically, it says the curve in the KNO3 line. So remember, the KNO3 line, it's the blue line right here, and we can see that it's curved. So there's a curve right here. And this is in contrast to the red line here. So this red line doesn't have a curve. This red line is a straight line. So the slope is a word for rate of change. So the rate of change, that's just a term that means slope. So slope and rate of change are the same things. You might get questions on the GED that ask you to calculate the average rate of change, and they're just telling you to calculate the slope. So slope, rate of change. And what you need to understand here is that for a straight line, there's a constant slope. In other words, there's a constant rate of change for a straight line, such as the red line right here. And you could pick any 2 points that you want on the red line, and you could use those points and you could plug them into the slope formula and calculate the slope. And whatever 2 points you pick on this line, you're still going to get the same answer for the slope, because the slope is constant for the red line, because it's a straight line. However, for a curve, like the blue line here, for a curve, the slope of a curve changes from point to point. So the idea here is that there's a constant rate of change for the red line as temperature increases, but for a curve here, we see that there's not a constant rate of change, okay, because the rate of change of the curve is going to change from point to point. Not super important to understand, but I just wanted to explain what they're going for here. But again, your best bet is just process of elimination to get a question like this right. Now we come to question 4, which says that researchers collected data to determine volumetric bone density for 4 samples. The data are recorded in the table. What is the average bone density for the samples provided? So you can go ahead and pause the video, try to figure out the average bone density for the data samples provided, and then we'll go over how to do this. Okay, so this is one of the few types of questions on GED Science that you do need to have some background information to get the question right. So what we see, first of all, you have to understand how to calculate the average, and that's probably the most important thing to get this question right, is to know how to calculate the average, but you also have to know how to find the density. And here's a little hint. Let me give you a clue here. So if you look at the answer choices, let's look at the units. So we see grams per centimeter cubed. So each answer choice has grams per centimeter cubed. So this is just like a division line, right? So that means grams divided by centimeters cubed. So if you don't know the formula for how to calculate density, which I'm going to show you in a minute, if you don't want to memorize that, okay, you don't necessarily need that to get the question right, because just by saying grams over centimeters cubed, hopefully that should tell you that to get density, you're going to be taking the grams and you're going to be dividing it by the volume of the sample. Okay, for each sample here, you're going to do 6.8 divided by 22.6 or whatever the mass is. So you're going to take the mass and divide it by the volume for each sample. That's going to give you the density for each sample. So if you don't know that formula for density, then hopefully you could just see the units here and reason your way through it. But if not, you're going to have to know the formula for density. So you're going to have to get the density for each sample, and then after that you're going to have to also get the average. So let me show you how to do that now. Okay, so this is the formula for density, and you can memorize this, put this in your notes. Density equals mass divided by volume. So for each sample, what we need to do is we need to find our density, and then once we found the density for each sample, we're then going to take the average. So for sample 1, we have to take the mass and we have to divide it by the volume, or the mass divided by the volume. So the mass was 6.8, all right, and it was 6.8 grams, and so we have to divide by the volume, which was 22.6 centimeters cubed. All right, so we've got 6.8 grams, and we're going to divide by 22.6 centimeters cubed. So let's do that math here. So I'm going to calculate this in my calculator right now that I have off screen. So we should get about 0.3 as our answer. So 0.3, so the density for sample 1 is 0.3, and it's 0.3 grams per centimeter cubed. Right? So we then have to do this for each of the samples. So that's for sample 1, so let's do sample 2. So again, for sample 2, we have to look back at that chart, right, and we have to know that the mass is 1.7. So again, I'm just pulling that mass from the chart. It's 1.7 grams, and I'm not going to write the units for each calculation like I did for the first one. So we've got 1.7 grams, and then for sample 2, the volume is 5.4. Okay. And so again, we just do a division. 1.7 divided by 5.4. And so after you do that, you should get about 0.31, and we can round that to 0.315, so something like that. And so since it is a multiple choice test, depending on how you round, your final answer might be a little bit different, but since it's multiple choice, it shouldn't matter too much because you should get something close enough no matter how you calculate it that your final answer shouldn't matter too much. Okay, it shouldn't matter that much for your final answer, I should say. So now let's look at the third sample here. And I'm going to go through the third sample calculation a bit faster now because hopefully you're getting the point. All right, so because we're just doing the same thing, we're going to take that mass, which is 3.6, and divide it by the volume, which was 11.3, and so we do that in the calculator. We do 3.6 divided by 11.3, which gives us about 0.32. Okay, and so again, I'm going to crank through sample 4 a little bit faster now because hopefully you're getting the hang of it, because all we're doing is we're just taking that mass and dividing it by the volume. So again, we're going to do 5.2 because that was the grams in the chart, that's the mass in the chart, and we're going to divide that by our volume. So we do 5.2 divided by 17.4. All right, 5.2 divided by 17.4, and that gives us about, let's say that's about 0.3. Okay, so now it's time to calculate the average. So after all of that work, we now have to calculate the average. So the way that we do that is we're going to take all of these numbers. So we're going to take our 0.3, and we're going to take all the numbers in our data set that we have here. So we take the density from each sample. So we take our 0.3, we take our 0.315. All right, we add all of the densities up. So we do 0.3 plus 0.315 plus 0.32. Plus, you guessed it, plus 0.3. Okay, so to get the average, you add up all of the numbers in your data set. So in this case, the data set is just the densities for each sample. So add up all of these numbers, and then you divide by the number of samples. All right, in other words, the total number of numbers in your data set. So we've got 1, 2, 3, 4 numbers that we're adding up, so we need to divide by 4. Okay, and knowing how to get the average is really important. Another word for average is mean. So for mean, median, mode, and range questions, you use the same process to get the mean. So we add these up. So in my calculator, I'm doing 0.3 plus 0.315 plus 0.32 plus 0.3. Okay, so let's add up all of these numbers here, and before we do our division, let's see what we get. So adding these numbers up, you should have 1.235. Okay, you should have a number that's about 1.235, and like I said, if you round it a little bit differently than me, your number might be a little bit different, but it should not be significantly different, okay? And so then we're going to divide this by 4. So let's do 1.235 divided by 4, and your answer should be about 0.3. I have 0.30875, so we can say that's 0.3, let's say 0.309. We could even round this to 0.31 to be more exact. Okay, so you should have a number that rounds to 0.31, whatever you did, or something very close to this, depending on how you rounded in the intermediate steps. But like I said, for a multiple choice question, okay, if you round differently, depending on how you round differently in the intermediate steps, your answer should still be very, very close to one of the multiple choice answers. So now coming back to our answer choices, we have 3.2, 0.36, 0.31, and 0.03, and so we know that 0.31 is the correct answer, so let's check that out here. And so then here is the explanation. So it tells you here that it has the question overview, and it says the correct calculation is to first divide the mass by the volume for each of the 4 samples, and then the average, and then average the 4 densities, and then finally you need to round the answer to 2 significant figures, which is basically what we did here. And so you can pause the video, take your time to read this if you want, and then let's move on to the next question. Just kidding. I'm going to cover the next problem on part 2. So your next step is to either go watch part 2 or to watch my free GED Science practice test for more awesome GED Science tips to help you pass GED Science. And make sure you click subscribe down below for more videos like this if you enjoyed this one. This is Parker from Test Prep Champions wishing you the best of luck on your test prep.